Hi again, guys. Just a quick little overview of some of the equality stuff. I kind of mentioned it in some of the other things I've done up for you, but equality is what we're thinking about in this particular example now, or this particular go around. Important things to remember here when you're doing something is that if I have any equation at all, so if I have A equals B. Anything I do addition or multiplication wise, as long as I do the same thing to both sides of this symbol, all is good. So if I want to add C to both sides of this symbol, so if I say A plus C is equal to B plus C, if A is equal to B, then A plus C has to equal B plus C. If I say A is equal to B, and instead of that I say A minus C equals B minus C, again, perfectly fine because I've done the same thing on both sides. And if I was to say A times C equals B times C, again, this is all perfectly valid rules. So this would be rule number 1, number 2, number 3, and there's one little catch with number 4. You can probably already guess what it is. That is going to be A over C is equal to B over C. The catch to this one is that so we keep closure enabled, C in this particular case can't be 0 because something divided by 0 is undefined in the set of real numbers. This whole idea is the whole crux of how we simplify absolutely everything. So when you looked at how we transpose formulas or how we simplified some polynomials, or even how you saw me walk through some of the order of operation examples, all the same idea. Anything you do to one side, you have to do to the other if you want equals to still be, because if both sides are the same, you got to do the same thing to both sides. Now, along with equality, we have an inequality thing. Not sure just how familiar you guys are with the whole inequality thing yet. I know it throws a couple of people off, and sometimes it can be a little tricky to deal with. The rules are really about the same. Okay, so big thing here to think about is that you have for your equality, you've got a couple of inequality symbols. So some inequality symbols you need to know about are not equals, which we're not all that worried about at the moment. You have less than, you have greater than, you also have less than and equals to, or greater than and equals to. These are really the ones I'm worried about for this part of the inequality, not so much this. So when we're thinking about greater than and less than, so if I say A is less than B, so that's my statement. Now, whatever I do, if I do the same thing to both sides, A is still going to be less than B. So if I add A plus C is still less than B plus C. That's true. A minus C is still less than B minus C. Yep, also true. A times C is less than B times C. Again, also true to a point. There is a condition on this one. That's when C is greater than 0. If c is not greater than 0, then a times c will be greater than b times c. Okay, when c is less than 0. So keep an eye on that. That's one of those little gotchas. And we have the same sort of thing will happen here in our fourth rule. So the rules are actually all the same. You just have this one little gotcha on it. Well, I guess technically there's two gotchas. The c can't equal 0 either. So if I have a over c is less than b over c when c is greater than 0, and a over c is greater than b over c when c is less than 0. So if c is negative, my sign flips if I'm doing any kind of multiplication operation or division operation. That's all that really means. So other than that, your equality and your inequality work the exact same way. These are just a couple of things you got to watch out for. Is that the multiplication, depending on what you're doing with the multiplication, can actually flip the value if you're doing an inequality. But you actually work through the inequality just like it's an equals equation. Just keeping an eye on this part here. Okay, let me see if I can do a numeric example to just clarify things. So clear. Okay, so if I say a is less than b, so let's pick a couple of values. Let's say a is equal to 10 and b is equal to 13. I was about to say 3, but then my inequality would have been wrong. So now let's say c equals 3. So let's go through my list and see what happens. So apply rule 1. A plus, let's use the real numbers. So 10 plus 3 is less than 13 plus 3. That looks like it makes sense. 13 is definitely less than 16. We're good. 10 minus 3 is less than 13 minus 3. Well, that's 10, and that's 7. So, yep, that's true. Now, this number is above 0, so 10 times 3 is going to be less than 13 times 3. So that's going to be 30 is going to be less than 39. Right again. And I'm not going to do the division one because I'll end up with a bunch of decimals. So let's see, what if we said that a equals 10, b equals 13 still. This time, let's say c equals minus 3. So we have 10 plus minus 3 equals, is less than, 10 plus minus 3, or 13, 13 plus minus 3. So that's going to be 7 is less than 10. Yep, that's correct. 10 minus 3 is less than 13 minus 3, which is going to be 13 is less than 16. Again, correct. Now, this time we'll say that 10 times minus 3. Now, note this is negative. Because this is negative, this sign has to flip to become greater than 13 times minus 3. That's going to be minus 30 is greater than minus 39, which is true because the lower you get, the smaller the number is. So it's important to just keep an eye on things like that when you're doing inequalities. We don't do a whole lot of them, but we do enough that it's important. Anyway, that's it for now.